3C is dividing radicals. For example 1, we're going to simplify 3 square root of 3 over 4 square root of 6. The reason why we have to do anything with this is the denominator has a square root in it. Anytime you have a radical in the denominator, it's not simplified. So we need to move this square root elsewhere in the problem to rationalize. It's called rationalizing the denominator. Right now the square root of 6, that's an irrational number, so we need to rationalize it. So first we look, this denominator is a monomial. So when you have a monomial in the denominator, what you're going to do is you're going to multiply by something that's equivalent. Always with these problems, you're multiplying by something equivalent to 1. Because we're not going to change the value of this problem. When you multiply something by 1, it doesn't change the value of the problem. It's just we're manipulating it so then the square root of 6 is no longer going to be there. We're going to have a rational number in the denominator. So what you do with a monomial is you multiply by the radical. So this is a square root, so we're going to need 2 square roots. So we have a square root of 6 times another square root of 6. So that's going to cancel that square root out. What you do the denominator, we also have to do the numerator. So put a square root of 6 on the numerator. Now we have a monomial times a monomial in the numerator, so that's 3 square root of 6 times the square root of 6 is 3 square root of 18. In the denominator, we have 4 square root of 6 times the square root of 6 is 4 square root of 36. Now I look to simplify each term. In the numerator we have square root of 18, so you can take out a 3 from that, because you have a square root of 9, that comes out of 18. So the 3 from what's already here, times the 3 from simplifying the square root of 18, what's left over is the square root of 2, over 4 times square root of 36 is 6. I carry this down a little bit. So in the numerator we have 3 times 3 is 9, square root of 2. In the denominator you have 4 times 6 is 24. Now we're looking at the coefficients of the numerator and the denominator here. 9/24 can be reduced. So you always at the end look to see if you can reduce the problem. So divide top and bottom numerator and denominator by 3. You get 3 square root of 2 over 8. And that's your final answer. You look, the denominator has a rational number in it, so that's exactly what we wanted. Moving on, example 2, we're just going to, again, simplifying, but now we have cube roots. So cube root of 10 over the cube root of 2. With cube roots, you just can't multiply by, and again, we have a monomial in the denominator here, so again, we're going to do the same thing, is multiply by that monomial, the radical. But if you just multiply by the cube root of 2 in the denominator and numerator, the denominator, cube root of 2 times the cube root of 2 is the cube root of 4, and the cube root of 4 does not simplify down. The cube root's still going to be there. So we can't just multiply by 1 or 2 together. We're going to multiply by 3. So you have a cube root, you need to multiply by 2 more, or 2 cube roots of 2. So looking at the denominator here, cube root of 2 times the cube root of 2 times the cube root of 2 is the cube root of 8. And hopefully you're thinking right now, cube root of 8, that's 2. So yes, that's the reason why we have to multiply by 2 of them. So you get it, so it simplifies out. In the numerator we have the cube root of 10 times the cube root of 2 times the cube root of 2, and that's the cube root of 40. Looking at simplifying this, cube root of 40, that's the cube root of 8 can come out of that. So that's cube root of 8 is 2. Cube root of 5 left over cube root of 3, or cube root of 8 is 2. Now we're going to look to simplify. We have 2 over 2 that cancels out, and what's left? So there's a 1 on top here. 1 times the cube root of 5 is the cube root of 5, and in the denominator we have a 1, but dividing by 1 doesn't really do anything, so we're just going to leave this cube root of 5. It simplifies to. That's nice. Some of you might have seen at the beginning we could have done that right away, but this is the general process that works every single time. Sometimes there's a shortcut. We could have just divided underneath the radicals. All right, moving on. So there's another way, another process you have to do, and this is when you have binomials in the denominator. So this is a binomial denominator. There's two terms. That's what binomial is, two terms. So there's two terms here. When this happens, we have to multiply by something a little different. We're still going to multiply it by something that's equal to 1, but now we're going to take and switch the sign of the radical. So wherever the radical is, you switch this sign. And we're actually going to multiply by the whole denominator. So it's 3, instead of a plus square root, it's going to be a minus square root of 5x to the third. And what you multiply the denominator by, you must multiply the numerator by it. Same thing, so it's equivalent to 1, so we're not changing the value of the whole problem. So now when we're looking at multiplying this out, we have a binomial times a binomial in the numerator, and a binomial times a binomial in the denominator. So when we do this, I'm going to multiply out the numerator. 2 times 3 is 6. And we do 2 times a negative square root of 5x to the third is a negative 2 square root of 5x to the third. And then we have square root of 3x to the third times 3. That's a positive 3 square root of 3x to the third. And then square root of 3x to the third times a negative 5, or square root of 5x to the third. It's negative square root of 15x to the sixth. And then in the denominator, so you got to be very careful how you multiply these out, because you can miss something quite easily. So 3 times 3 is 9. 3 times a negative square root of 5x to the third is negative 3 square root of 5x to the third. In the middle here we have square root of 5x to the third times 3 is a positive 3 square root of 5x to the third. And square root of 5x to the third times a negative square root of 5x to the third is a negative square root of 25x to the sixth. Now let's continue this down. I'm going to keep going down since I don't have a lot of room. Now we're looking to simplify each term just like we did before. So 6, nothing to simplify there. Negative 2 square root of 5x to the third, just x to the third can be simplified. That comes out as an x. What's left over on the inside is 5x plus, and in the second or the third term here, we have a 3. The only thing that can be simplified is the x to the third. Square root of x squared is x, leaving you with an x inside and a 3. And the last term, square root of 15, you can't simplify, but square root of x to the 6 is x to the third. And then the square root of 15 stays underneath. And then the denominator, this is where a lot of your work pays off. So we have 9, and you have negative 3 square root of 5x to the third plus 3 square root of 5x to the third. Those are like terms, and they're opposites. So those are going to just equal 0, so they just go away. And then the last term there, we have the square root of 25 is 5, and the square root of x to the 6 is x to the third. So now we look at all of our terms. So 6x square root of 5x, 3x square root of 3x, x to the third square root of 15, no like terms there. And 9 minus 5x to the third, no like terms there. If you look at the coefficients, 6, 3, negative 1, 9, 5, nothing in common to reduce. X, x, x. This 9 doesn't have an x on it, so we cannot reduce all the x's out, so simplify. So this ends up being your final answer. It does not look nice, but this is the answer. The reason why it's the answer is because look at the denominator. The denominator, 9 minus 5x to the third. No square roots, no radicals left. So perfect. We're done. All right, thanks. Come to class with questions.